All right, we are checking out lesson 9.2 today, so we're looking at reflections, similar to translations that we talked about yesterday, but some key differences that we need to pay attention to. So let's start at the beginning with our learning goal. We are still looking at using coordinates. So our learning goal is I can use coordinates as in an XY ordered pair to describe the effect of reflections on 2D objects or 2D figures. So as we finish, your homework today will be digits 9.2. And today is February 6th. So let's review the exact definition of a reflection. You may think of a reflection as a flip. We talked a little bit yesterday how this is like the mirror image. So this is another example similar to a translation that is a rigid motion because we don't change the size or the shape of our figure. It just flips the figure over a line. And that line is important because that is our line of reflection. And that helps us know where to create our new figure. So sometimes a point might be on the line of reflection, and if that's the case, then its image is going to be the same as itself. So if A is on the line of reflection, then its image, A prime, will be identical to point A. If, however, point B is not on the line of reflection, then B and B prime are going to be on opposite sides of the line of reflection, which is what happens in most cases. So these are going to be on a line that are perpendicular to the line of reflection, and these points are going to be the same distance from the line of reflection. So if we're looking at this image here of this square, and this dotted line is my line of reflection, then each of these points need to be reflected across this line, meaning that this point, which is 1 unit away from the line of reflection, needs to have its image mapped 1 unit away from the line of reflection. Similarly, down here, we could map this point here. And then this point is 1, 2, 3 units away from the line of reflection. So I need to map its image 1, 2, 3 units across the line of reflection. So this, we would map this image right here. So remember, a rigid motion, we didn't change the size or the shape, but we simply flipped it across this line. And because it's been reflected across that line, if we were to fold that plane, that coordinate plane on that line of reflection, everything should line up exactly. So on part 1, go ahead and pause the video if you need to, but let's take a second to circle which of these 3 transformations is a reflection or a flip. If you need more time, pause and really study. And let's go ahead and eliminate some of these that for sure cannot be the answer. I'm first going to cross out our third option. This is a great example of a translation like we talked about yesterday, where we started with this triangle ABC and all we did was slide it over. That's a translation, so it cannot also be a reflection. To be a reflection, I'm looking for a line of reflection in between the original image and the map of its new image. So on this first one, it looks like the y-axis could be our line of reflection, as points A and A prime are each 1 unit away. But as I look at point B, which is 2 units away from this line, I notice that B prime is 3 units away. So that doesn't look right. In the same way, point C is 3 units from this line, and C prime is only 2 units. So all 3 points have to be reflected the same way, so this cannot be a reflection. However, my y-axis does demonstrate a great line of reflection in the second example. Point A is here, and A prime is found 1 unit away, reflected across the x-axis. Point B is 2 units from the line of reflection, and B prime is 2 units to the left. Point C is 3 units away from the line of reflection, and C prime is 3 units on the opposite side. So this would be an excellent example of a flip. And imagine folding this coordinate plane up on this line. A and A prime would match up, C and C prime would match up, and B prime would match up. And part 2, which graph shows a reflection of triangle DEF across the x-axis? So first, let's draw attention to our x-axis in each of these drawings. So we're looking for the one that shows a reflection. All 3 of these have triangle DEF, but I need the one that is reflected or flipped across the x-axis. Go ahead and pause the video if you need to, if you need more time to look. I'm going to notice right off the bat that figure number 1 seems to be a translation. Point D has moved down 2 units, E has moved down 2 units, and F has moved down 2 units. So this seems to be a translation. I'm noticing that figure number 2 definitely looks like a reflection. However, it appears that we've reflected across the y-axis. So while D is here, D prime is equal distance. E appears to be reflected evenly to E prime, as does F to F prime, but I'm not trying to reflect across the y-axis, we're trying to reflect across the x. So let's see if this third figure will fulfill that. So let's look at point D. I am 3 units above the x-axis, so D prime should be 3 units below. That works out. Point E is 2 units above the x-axis, and E prime is 2 units below. That checks out. Point F of my triangle crosses below the x-axis, and that's fine. It's 1 unit below the x-axis, where F prime is 1 unit above. So those are equal distance from each other across the x-axis, which is perfect. If I were to fold this coordinate plane on this line on the x-axis, F and F prime would match up, E and E prime would match up, D and D prime would match up. So this is a great example of a reflection. Moving on, let's talk about how we can use our arrow notation to map these images. So looking over here, we have triangle A prime, B prime, C prime in blue. This is the image of triangle ABC after a reflection across the y-axis. So here's my line of reflection. If I want to use arrow notation to show how each vertex of triangle ABC maps to its image after the reflection, then here's how I'm going to do that. I'm first going to label point A, and the coordinates of this point are -1, +4. I'm going to use my arrow, and I'm going to read that as maps to. So this reads point A at -1, +4 maps to A prime, and then I'm going to list the location of A prime, which is +1, +4. Point B, and I'm going to name its location. Point B is at -1, 2, 3, and +2. So point B at -3, 2 maps to B prime, which is located at +1, 2, 3, +2. So I read this as point B at -3, 2 maps to B prime at 3, 2. And finally C, which is located at -2, -1, maps to C prime, which is located at +2, -1. So you'll notice that this is a little different than how we mapped the points and used arrow notation with translations. Each point in a figure, when we translate it, has the same relationship when it moves. However, when we reflect, we have to map each point separately because they're not all the same distance from the line of reflection as the other. Let's check out our rectangles here. We have rectangle PQRS, and we want to describe in words how to map PQRS to its image P prime, Q prime, R prime, S prime. And it's always a good idea when you see the names of these figures to trace them, as I just showed you, because you might have noticed that in PQRS, we were moving counterclockwise around this rectangle. But in P prime, Q prime, R prime, S prime, we're moving in a clockwise fashion, which tells us that this is definitely not a translation, that we must have flipped this somehow. So if I'm going to describe in words how to map this image, then I need to describe what kind of transformation happens. So I could say that rectangle PQRS reflected, but then I need to say what line it reflected across. So clearly it's reflected across a vertical line. But in this case, it didn't reflect across the y-axis. It appears to have reflected across this line. So we need to think about what I could call this line. So think back to when we talked about vertical and horizontal lines. If I have a vertical line here, it means that all of my x values are the same, right? No matter how far I go up or down this line, all of my x values are +1. So I'm going to call this line x equals 1 because no matter where I travel on this line, that x value never changes. So if I want to describe this in words, I could say that rectangle PQRS is reflected across the line x equals 1. And now if I'm going to use arrow notation to show how each vertex maps to its image, then I'm going to start with point P and I'm going to label it. So point P, which is at +4, +3, maps to P prime, which is at -2, +3. Next, I'm going to describe point Q, which is at +2, +1, and Q maps to Q prime, which is at 0, 1. It's actually on the y-axis. Point R is at -2, +5, and that maps to R prime, which is at -3, -2. And S, which is at 7, 0. Go over 7 and up 0 to get to point S. And that maps S prime, which is at -5, 0. So once again, in words, what happened is that we reflected PQRS across the line x equals 1. And this is how we mapped that rectangle to its image. Looking at LMNP, so LMNP, which is moving in a clockwise direction, we want to describe in words how to map LMNP to its image, L prime, M prime, N prime, P prime. So again, I'm noticing that I'm moving in opposite directions. Clockwise to counterclockwise. So that tells me